Hello viewers, today we are performing the experiment on Bernoulli's theorem apparatus to verify the Bernoulli's theorem. The experimental setup is, you are seeing the experimental setup. In the experimental setup, we need the piezometer for measuring the pressure head, and we collect the water in the collecting tank. By using this stopwatch, we measure the time, and we have the sump. Through the sump, using the centrifugal pump, the water is being flown in the system. So this is the complete setup of the Bernoulli's theorem apparatus. Water is being flown into this through this pipe. As you can see, the pipe is having the varying cross section. The water is flowing through this, so it is a tapering pipe. At here, the pressure is minimum and water head is minimum, and here the water head is increasing. So we can see the pressure, drop in pressure, and then there is a rising pressure. So we will note down all the readings of pressure heads into these pipes, and I have noted down the readings of this pressure head as varying from 14.5. At the lowest it is around 8.5, and then again it goes on increasing up to 10.5 or 11. So this is how the pressure heads are noted down. After noting down the pressure head, now we will start collecting the water into this collecting tank, and then in this collecting tank we will note down by the stopwatch, we will note down what is the time taken. So in this stopwatch, we will first let the water rise up to this 10 centimeters, and then we will note down the time. So now the water, as you can see, it is rising through this collecting tank. So water is being collected in the collecting tank. We will start the timer once it is marked up to 10. Yes, so now I have started the time. So we will measure the time required in the seconds up to for 10 centimeters rise. So it is here, you can see the 10 centimeters are already been marked. So on this, when the water touches this second mark, I will stop the clock. So now you can see the water is rising. I have stopped the clock, and the time taken around is 25 seconds, as you can see. So this is noted down as 25 seconds. By noting down the time, we will measure the discharge through this pipe. Discharge divided by area will give all the velocities.
First, the actual discharge is calculated as 0.00528 meter cube per second. In this diagram, we are able to see the sections, 11 sections, the cross-sectional area along these 11 sections, and the velocities along these sections. So the velocity is calculated by discharge upon area, and the pressure head is recorded as meters in piezometers. The velocity head is calculated as v square by 2g, and the pressure head is converted into centimeters. The total head is calculated as the addition of velocity head and the pressure head. The total head is along these 11 cross sections. In these graphs, we are able to see the graphs of pressure head, velocity head, and the total head along the 11 cross-section points in this varying pipe section. This proves the Bernoulli's theorem, and we have successfully verified the Bernoulli's theorem.